Good afternoon. I would like to start the performance session. We have three speakers here. The first speaker, Professor Sven Tavelin from Chalmers University of Technology. He's a key person from the NordUnet and the SONET networks too. The second speakers will be Anne Harding from HEAGINET. And third is Nicolas Simmer from Dante. Yeah, please, first speaker, start.
Okay, thank you very much. I'm coming from Gothenburg in Sweden, you know, on the west coast of Sweden. As we usually say, the front side of Sweden. There is no one from Stockholm here, I see. Okay, and I can say it. Just now I'm going to talk about really about measuring, the measurement on the network, more than about the quality of service itself. Because quality of service measurement or understanding quality of service is the same as understanding the networking. And you need to understand, that is the crucial part of everything in order to be able to work with it, to be able to improve on it, and so on. And in order to understand, we need to observe the network. It is my experience throughout the years that even, I think most of us here, believe that we understand how internet is working. But if you are really probing and see what is happening, you will be astonished. And that is, I think, always the case when we're looking at very complex systems. And the internet is a complex system. I've been looking at complex software. I didn't understand. And I say, just how could they design software in that way? And so on. So we need to understand and we need to observe. The reason for making this presentation is that I recently started a product which is called the MONET. It is financed by the Swedish University Network, but it is regarded as a research project. And one of my reasons for that is that when it is a research project, I can get funding for a number of years, and I can hire the only type of people working at the university which has time to think, evaluate, and so on. That is PhD students. The idea is to collect traces on the network, on the 10 gigabit backbone, and keeping that and to analyze it afterwards to see what is really happening, how much of it do we understand, and so on. The volume of the traffic is, of course, so immense, so there is no possibilities of keeping it forever. So it will be done in campaigns, that we are catching information, traffic traces, and put it in a sort of library, and then for a few, perhaps months, analyze it, compare it to previous ones, and so on, and later on make a new campaign and get new information. The idea is, as a scientist, as I am, to really get a time library with sort of snapshots, so we can go backwards. If we, say in 2 years, find something very special on the network, and say, oh, has this been seen before? Then we can go back and say, did it exist? Oh yes, it did exist, but it's such a tiny portion, so we didn't observe it at that time. And here, no, it didn't exist at all. Well, that is relevant, and that is how typical scientists are working. Compare what is changing, and so on. The original configuration, you recognize this. This is not very impressive at all. We are using DVDM equipment from the vendor of the capacity, which is Telia in our case, and of course we are owning routers which are attaching to that. The only thing is that there are two connections there between, one in both directions. The measurement configuration will be this one. The crucial part is that we are starting with splitters, optical splitters, which means that we are detaching and putting on equipment, pure passive equipment there, which are taking off, and then we have to decide how much, and we have decided to go for 80-20% solution. So 80% of the power budget is passing through, and 20% is going this way. And of course, minus some minor loss altogether, of course. And we're doing it in both directions. And there it is coming, and this means measurement computer. And the idea here is to have a computer with rather many fast disks, because we have a performance problem here. And the session here is called performance, so therefore I think that is the one reason for putting it here. And that is, if we're getting 10 gigabit per second, which could be which is the nominal speed, And of course we could approach it for a short period of times. It is an awful lot of data we get. If you take it raw, it means 1.2 gigabytes per second. And try to store that on a disk. Fast disks usually give you about 80 megabytes per second. In this case, we are trying to use 6 disks in parallel, and we have been measuring and getting about 480 megabytes per second in sustained store rate. Now, that is artificial, not measuring. It is just trying to store as much as possible. On the other hand, each computer contains 2 processors, rather fast processors each. So I think we have the capacity in computer power also. And when we got as much as we want to have stored on the disks, we need to do the same with another computer. This is pure economical reason, because the first attempt from our point was using one measurement computer, 2 interface cards, and a number of disks. But when talking to people, the measurement cards are coming from New Zealand. When talking to them, they said, oh, but remember one thing. What is costly here is the card sitting there. It is not the computer. So why should you try to put it in one computer? Buy 2 instead. And that solved a number of issues, doubling the capacity, but also the number of buses which you can use and so on. And then, of course, just to do the processing afterwards, we are attached to gigabit Ethernet switch, which is just locally sitting on the computers, and that is attached to the router. Why didn't we select anything faster than gigabit? It depends on the cards available here on the router. It is very expensive. You know, the router is a fast router, so therefore the cards are expensive there. And we happen to, in most cases in Sunnet, have gigabit ports. And that is sufficient to do the processing afterwards, setting it up, and do a number of things, and then finally get it through the network Sunnet down to my university charge. Those working with measurements will recognize that this is a very standard way of doing it. The situation with the project is that I want to share with you some of the experiences we have got so far. And some experiences are perhaps not what you expect it to be. First, what can the traces be used for? Well, traces, they are raw material, so you can do rather much with it. You can, for example, network statistics. Now remember, routers do it also, so there's no major news about that. But you can have other type of statistics, which routers don't give you immediately. You can be studying the type of traffic. I think, and that is rather important. I had in Sunnet rather major discussions what Sunnet is used for. Is it used for research? Is it used for student work? Or is it downloading films or music? And so on. And people, they disagree. That is the only agreement we can get. They think it is very different. And I think that is a bad situation. Of course, we should know what the network is used for. It is part of the university's budget, and of course, they are interested to see that their money is spent in the best way possible. Then, as I said, the network changes over time. I think that is important. Usually, we are at the moment just measurements and knowledge. Currently, we're doing this. And sometimes I'm somewhat pissed off when I see current papers. They're doing measurements and then they compare to something which happened 12 years ago. Because there is a measurement at that time which is somewhat similar to what they're doing. And then they take long-drawn conclusions of what has changed, which I think sometimes is wrong. Applications are important. And sometimes they are behaving rather badly. I had a project where we compared the way my department, the computer engineering department at that time at Chalmers, with, let's say, ample network capacity. How we were using the network compared to a situation where a student came from Sri Lanka at the Technical University in Moratuva. The entire university there had about the same networking capacity as our department had. So she was comparing it. And the obvious first choice, the obvious first finding we found out was that the length of the TCP connections was very dissimilar. At Chalmers, they were very short. We remember it was 11 or 13 packets, typically. And we looked, why on earth? And then we found out there was one machine doing that. and we found out that it was an administrating machine, a girl doing all, you know, exam reporting to our computers for students. And that application, Lawdoc in our case, was so silly done. So her computer was talking TCP to the server. Are you there? Have you anything to say? No. Okay. 2 seconds later, that is it. Are you there? Anything to say? No. And of course, this destroyed everything in a way. But also, how on earth can you make an application in that way? Question mark, and you see the question mark. It's silly. I have other horror stories also, but I shouldn't take them here. Delay properties. We are talking about network, but network quality, that is a difficult issue. And there are situations where delays, real-time behavior is important. There are reports in Sweden, for example, which are given to the industry about the possibility of controlling manufacturing machines over internet in real time. So it could be, for example, a situation that there is a company in Sweden that need to have very major welding done somewhere, and they go into Europe. Is there anyone that can do it? Yes, there's a Spanish company. Say, we have the equipment, we're sitting on the internet, you can control our machines directly. So the welding machines in Spain will be controlled from Sweden. Now you need real time. And delays are important. Usually today we are rather often say, oh, it works. Sometimes we say with users, oh, what a delay. But do we know about it? Rather often not. And that is also coupled to network stability. When the current SUNET was established, we decided to change from SDH protection to IP protection of the connections, using capacity which was not protected by itself. And then, of course, using 15 seconds before IP, the router starts to change routing is not a very good choice. So we reduced number of screws to change it down to a few seconds. But somewhere here we stopped without knowing really why, because we dared not screw it, because it could become unstable. Do we know where it would happen? No, we don't know. So network stability and delays, that is coupled. And then we shouldn't forget network forensics. You can use traces to see what the network has been used for, and perhaps sometimes supporting to catch misbehaving people or misbehaving services and so on. And that is a part of one of the future problems coming here. Now, this is not a complete list. Of course not. You could go on. A number of bullets more. That's why I say traces, it is a raw material you can use for a number of things. Remember, though, that there are things you cannot use, there are a number of problems. For example, you cannot have, there is no guarantee that you get full TCP connections. If there is routing inconsistencies, or nowadays rather common, that you are taking that path in that way and then this path back. You can see half the connection, perhaps, if you're measuring here. You must be aware of that. Performance issues. 10 gigabit per second, very much data, even fast computers. Of course, nowadays we're always talking about PC type of computers. It is very much for them. We have started with using 6 fast disks, put them in parallel, having software or hardware to put them, using them in parallel, and getting 480 megabytes per second. Strangely enough, it is more than we theoretically should have reached. More. That is not the usual case. Usually you're calculating something, this is the most, and then you're getting somewhat lower. I think we calculate to 470. But that's strange. That is about 3.8 gigabits per second. That is not 10. What do we do? More disks. We're getting problems with the buses. More buses. Oh, they don't exist. So, we are on the verge of getting real problems. Now, I hope that there is something that will make me survive, and that is this. We will not store user data, meaning in long blocks, most of it will be just thrown away. And of course, the links are not fully loaded. So, I think I will survive. But when we're getting to more and more usage, and if we are selecting, and in network forensics perhaps we need to take all traffic, all data, then we really need to know this. We have problems. Remember though that I improved the situation with having 2 computers. So now one computer is just about one connection, one link, not the opposite, because there's another computer taking care of that one. Observe one thing. There is no standard about trace formats. They are incompatible, really incompatible. There are a number of alternatives. It seems that everyone doing his software also decided on the new format. Just to mention a few, PCAP format. Of course, it's coming from the library libpcap. That is one. Rather commonly used, we have the DEG or ERF. It is really equipment from the New Zealand. They make good equipment and they decided for their own format of how to store it. Now it went from university and into company, and that is why it changed name. ERF, E is coming from the name of the company, Endes. But there are a number of versions of it. So it is not compatible even therein. Then we have the American activities in NLANR, and they have a fixed record format, they have a fixed record format plus, they have TSH, and for example the last 2, what are the difference? Not the major ones, but the last one has shorter timestamp than the previous one, saving a few, well, a few bits, 8 bits. Okay. We have CRL, originally came from Coral, and then there has been a rather long development of Coral becoming Coral Reef, and therefore there are a number of versions of that one also. And I could continue in this way. Now, are you stuck if you have succeeded? Of course, you will get one format when you're measuring. Are you happy with that one? Probably not. Can you do anything about it? Of course, there exist conversion programs, at least between some of these formats. But remember, converting usually means losing information. And sometimes it is crucial information. We can only keep information which are representable on both formats. And since timestamps is a very crucial information in all these packets, we need always to think about that, and that is one of the major problem areas. For example, it was not uncommon to start with of using the ordinary Unix system, timestamping meaning 2 integers. One, the number of seconds since the 1st of January 1970. Remember, these are always Unix machines. And the next one, the number of microseconds in the current second. But the number of microseconds, 1 microsecond on a 10 gigabit link, that is 10,000 bits. That is 1200 bytes. But it could be a number of small packets in that. And it will show up as if they happen simultaneously. Of course, they cannot do that. So we have a problem here. Timing is a problem. And if we're using that format, because there are other, for example, the DEG format, they have a better precision. If they are converting that to the first PCAP format, you are losing that extra precision. Is that important? Well, in our case, it is very important, because I need to take the traces for the traffic in that way and the traces that way and merge them into one trace. So I can see, well, that one sent and there was a response, that was, and so on. But I can't even merge if I don't get timing information correctly. Then we must also remember that the operating system must give a very high precision. The usual Unix style of 20 milliseconds precision, forget about that. 20 milliseconds is an eternity in this case. And then we have also the precision, but also the exactness. How close is it to the real time? Is that important? It depends on what you're measuring. If you're measuring, as I will do to begin with, at one place, it means that the computers should be synchronized in a very good way, but they are close. They are sitting on top of each other this way. So that I think we can synchronize. But if I'm going to make measurements, for example, traffic from Stockholm to Göteborg, and I want to study delays and, you know, a number of stuff there. Then we must agree on good timing, exact timing. And that is a problem. What can we do? Well, GPS is a very common way of getting good timing information. But we must remember in all these cases that we need to scrutinize how it is behaving. It could be the case that you're relying partly on the GPS giving you timing information. There is equipment giving 1 second clock pulses with extremely good precision. But the other part is taken from the operating system. And it could easily be the case that your Unix system or your Linux system says, oh, oh, sorry, I'm somewhat late in my clock. So I jump it, increase it somewhat, 20 milliseconds. It will show up in our traces, of course. It means that during 20 milliseconds, no one was using our connection. And that is very improbable. But it shows up in that way. It could also be the case that we are drifting apart, and that it could be solved in our post-processing, that if we know how much the situation here, and then we're measuring for 2 hours, and we know the situation here, now it is like this. And of course we can make a linear approximation and change timings, so we get a much better one. But if we are converting it into the wrong format, we are losing that precision. We must remember that. And it is a real pity that some of the most common ones, PCAP format, for example, has too low precision. Because some of the conversions you want to do from here to there, the only way is to go through PCAP format. On the other hand, we can do that software ourselves, adding to a new conversion program. There is something we need to do, trace sensitization and desensitization. I'm not sure if that is a good English word, but they are telling what it is. When we caught something, we need to see the timing. Is it okay? We need to do other stuff. Was the starting point correctly, and so on, and do the adjustments. Correctness, and so on. Sensitization, that is, we are usually catching too much. And there are rules about what we are, and I see I will have a real problem, so there are rules about what we're going to store and so on. So we need to remove. For example, I'm not allowed of storing user information, user data. But if I want to get BGP, also, that is routing information, I need to, at the first level, catch all packets, complete. And then immediately afterwards select, oh, this was a private packet, and cut most of it off. But if it was a routing packet, a BGP packet, I will keep it. And so on. We also need to change the IP numbers. And that brings us to the ethics issue. And some of you attending a previous meeting, a previous session today, where there were low discussions about it. There are people who think that internet is the last bastion of freedom, and therefore you should be allowed to doing anything, and everyone looking upon you doing that is wrong, completely wrong. On the other hand, the political debate currently is absolutely opposite. Network providers should give the police and authorities good help in tracing people and problems and enforcing laws and so on. The Swedish law is very clear. It is going to protect the privacy. And the Swedish government is talking to the European Union that they should change it into that direction. And of course, law is not changed, but anyhow. If we want to make the traces more anonymous, that is the IP numbers, because people think the IP number will reveal the person. To some extent it may be true, but okay, then we change the IP numbers. And we have some requirements on it. It should be done systematically, replacing each IP number with a pseudonym. It should be prefix preserving, so if there are two computers sitting on the same subnet, it should be two new IP numbers, which seems to be sitting on a faked but subnet, so that we know in that way. There are two well-known methods, prefix preserving and anonymization. One is very well-known, TCP DPRIV. It's almost standard, but it is table-driven. So it is depending on the order you are getting the traces. It builds a table, larger table. And that could be, of course, the output of the trace if you want to keep it. The drawback of that is that if I'm taking two places at the same time, which is true in my case. It will be different pseudonym in these cases for the same IP number. So I can't find that this was a response to that one. There is a news, well, not very new, but a few years ago, CryptoPan came, which solved this problem. It is really encrypting the IP numbers, but doing it in such a way that the prefix is always, it is prefix preserving. And it is always with the same key. Now we need to add a key. With the same key, we will always get, for one IP number, get the same pseudonym. And therefore, it will be working in both directions. So I can find out it is the same IP number, although I don't know which IP number. Well, of course, I realize that is somewhat fake because I have the key. But and then it is regarded as so good. So these type of cases has been stored online on the web, for example, in the United States. The project, and that is, I think, the last point, is in a way stopped at the moment. I have the equipment, I have installed it, as I showed on an earlier picture, but I need to have a permission from a research ethics committee in Sweden. And that is still, I'm still waiting for that. In the best case, it will happen the 20th of this month. And this really should be allowed this type of research. Okay, that was a short walkthrough. Questions? Or should we take questions late?
Thank you for the presentation.
Hello. By looking at your presentation, I saw that the general problem we are facing in such situations is time. What is the maximum resolution that you, in time measurements, that you can achieve, or you believe you can achieve, by using the equipment that you described? You're using GPS clocks, right?
No. But I have no idea which precision I can reach. What I was talking about here is that we should have the possibility of storing in a certain precision. And the DAG format, for example, is using also 32 bits for the part of the second, but it is binals. So it is 1 of 4 billion parts of it, which means even nanosecond level will be even less than nanosecond. Then the precision which we can store there, how good we can measure, that is another question. And I think that is, in the future, an upcoming problem. Using the GPS may give us currently good support, but I'm not sure. Faster networks makes the problem harder, and GPS will not improve.
Do you believe that choosing an appropriate operating system that has some sort of real-time capabilities, I mean, we should consider the fact that kernels may be preemptive, but an application that that uses the GPS signals correctly should have some sort of real-time capabilities.
In this case, the DAG cards, they have the possibility already, and they are attaching the timestamp already on the card. So I'm not depending at that moment on the operating system, but I have to prime it with the current time of day. And if I'm only measuring it at one place, that's not a problem. Which millisecond I'm doing the measurements, that's not important. But if I'm doing it in two places and I want to compare them, then this is really important. I think this is a problem today and a still more problem tomorrow.
Next question, please.
Okay.
Hello, can everyone hear me up the back? Okay. My name is Anne Harding. I'm from HEANet, but I'm standing here representing not only my co-authors Toby and Michal, but also the Géant 2 initiative for the Performance Enhancement Response Team. So what I'm going to do is take you through what is the PERT, why is the PERT, and how has it developed over the history of the project. I'm going to go into a bit of detail, and the origins actually go back quite far, surprisingly far, as you're going to find out. And it's been through a number of phases, an initial trial, then a pilot, and now a full production PERT. I'm going to go through the Géant 2 systems used to make sure that the PERT can do its job, and show you some of the specialist tools that have been developed for it. And then finally, I'll show you a typical performance case. In this one, it's a transfer of data from Fermilab in the US to Renater in France. Well, we heard at the opening plenary that despite the development of all these high-capacity WAN, research network and campus backbones, that the applications perhaps still aren't available, or the bandwidth perhaps still isn't high enough to take advantage of brand new applications. Whatever the future holds, we notice that we're still seeing end-to-end performance problems now where we should not expect them. And the conclusion that has been reached in this case is that maybe we need to look beyond the network. Maybe we need to look at things from an end-to-end perspective. And I'm going to mention end-to-end quite a lot here. All the way from the application through to the operating system, the TCP stack on the operating system, onto the campus network, from the campus network to the regional network, and all the way to the other side. So it's a joining of a lot of different factors which give performance. And I think previous speaker highlighted that quite well. As I said, the idea of a performance response team goes back quite far. It was initially proposed in Internet 2 under the End-to-End Performance Initiative. The idea was to have a group of specialists who'd be to network performance what the CERT is to network security. So that's available to investigate problems and coordinating among any relevant parties. The idea was to link the user and the expert to solve performance problems. Again, in the opening plenary, we heard that what researchers aren't necessarily interested in is our version of events. It's the user's experience that is important. Yet, in order to solve these problems, we have to translate ideas such as my application is slow into latency figures, expected throughput, and things like that. So that's a role of the PERT, to translate evaluation concepts into actual metrics. The Internet 2 concept remained theoretical as their initiative went out a different direction. But here in Europe, we moved to, in 2002, after a TFNGN meeting, the idea of a trial PERT. And this was taking place in year 4 of Géant, the final year of Géant. There were a number of participants, Italy, Tirrenia, Dante, Switch, Chestnut, HEANet, and Ukerna, but it was entirely dependent on volunteer effort. Interestingly, the case that I'm going to go through with you later came from this phase. It was, as I said, dependent on volunteer effort. Again, a mailing list was hosted by Switch where people would report problems and they would be discussed, and different experts in different areas would come together in order to try and solve the problems. And it also had some issue tracking software, Roundup, which is also hosted by Switch, so that you could, again, notice recurrences of problems, notice the same thing coming up, reuse the information. Well, what's in a name? The first email to the PERT discussed mailing list, which was the mailing list I mentioned previously, said the PERT should stand for the equivalent of CERT, Performance Emergency Response Team. Well, what's a performance emergency? So the second email said that perhaps the E should stand for enhancement. So it was finally agreed that the PERT should probably be called the Performance Enhancement and Response Team. And what that does is it retains enough of the previous connotations of the CERT. It's still got the idea of cooperative elements across different domains. But it removes the idea of emergency and adds the idea of enhancement. And that also broadens the scope of the PERT, because it's not necessarily just responding to issues. It's also a concern, it's also a concern with performance all round. After the trial PERT, Géant 2 activities under Service Activity 3 were concentrated in performance and allocated capacity for end users. There's that end users again. And the performance aspect of this is basically the PERT, the Performance Response Team. A pilot was set up starting in November 2004 with, again, a new email address for people to report PERT cases, and I'll go into a little more detail about who does that and how. A dedicated roster of case managers, and this is a big difference from the previous trial PERT. In this case, you could be guaranteed that if you sent an email to the list, there would be somebody assigned to look after it. It wasn't full-time at that time. The duty case manager would be spending maybe 2 to 3 hours per day working on open issues. In case you're wondering what type of issues they are, they tend not to be a large number of issues in one go, but each issue takes longer to solve than, if you're familiar with a network operations team, than with your average network operations problem. In addition, there was also a PERT wiki, which was used partially as a diary, so you can track the successes and failures of the pilot, learn what works, learn how to troubleshoot these type of end-to-end problems, learn what solutions had previously worked, and also to build up a preliminary knowledge base. Because one of the things that's very important about the pilot PERT, since we're going from end to end, is the vast domain of knowledge that's available. I mean, suppose you're an applications developer, you're an operating systems developer, you manage a campus network, you're all necessary, the knowledge that you would have was all necessary to try and solve PERT cases. The production PERT, as you can see, I'm standing here wearing my HEAnet hat, but there's an awful lot of other people involved, both in the production of the tools to maintain the PERT and keep it working, and also in the day-to-day operations. Well, who is the Xeon2 production PERT for? Initially, the people involved are the PERT customers, and I'll define who they are, and PERT staff. And what is it for? Well, the PERT undertakes to investigate any academic networked, and network is still important here, system performance problems. So if you're involved in a research project and perhaps your throughput to another site isn't what you think it ought to be, get in contact with your research network and get the PERT involved, because that's exactly the type of case it should be working on. We guarantee to investigate problems. Now, unfortunately, we can't always guarantee solutions, but we do guarantee to try and pinpoint where something might be going wrong, where it could be improved. And in addition to this, and again, I mentioned earlier, the enhancement idea rather than just emergency response, there's a consultancy service. If you're going to be planning a particular project and it requires some network facilities and you want to see, do you have what is in place? Is what is in place? Is it likely to work? Is it likely to perform as you expected? There's also a consultancy service available via the PERT as well. And when the production PERT kicked off from March 2005, we do have some cases on the books. More are always welcome. Well, I mentioned the PERT staff. There's actually a range of different types of people involved. There's the initial PERT managers who oversee the whole operation of the PERT. And then there's full-time case managers. This is the difference between the production and the pilot. Previously, people were only devoting maybe half a day. Now it's full-time, and any work that's not, any time during the day that's not spent actively working on PERT cases is to extend the knowledge base or to do the consultancy service. So there's people every week always dedicated to improving performance issues. In addition to this, and very important, are the subject matter experts. There are a range of different components in every application in order to communicate from one end to the other. So different people have different in-depth knowledge. While the case managers might have a broad knowledge of a range of areas, it's the subject matter experts that can get in there in depth and really understand and explain where things might be going wrong. There's also a PERT customer, which for the moment is generally NRENs and also particular projects too. And in addition to that, the PERT has a public-facing role as well, to educate not just the research network, but the world at large about network performance issues. And so that also involves the creation of a public forum. And obviously, if you're creating a public forum, you need to have forum moderators. In order to carry out its work, it's been necessary to develop some specific tools for the PERT itself. Actually, a lot of this work, I think pretty much all of this work has been done here in Poznan by PSNC. The main component is the ticketing system. What that involves is everything you'd expect from a ticketing system, ticketing management and notification. But it also involves some extra elements because the PERT case managers could be coming from a range of research networks. They're not all in one office like your normal operations team. So the communication and collaboration aspect of these tools is particularly important. And some of the things are there's automatic email and Jabber integration. So if you opened a PERT case and you have somebody associated with a subject matter in a particular area, you get an email and you get a Jabber room popped up and you can actually talk about and discuss the issue live there. And then this information is stored back into the ticket. So that really, really helps to progress the problems. In addition to that, there's still the PERT diary so that you can record ongoing experiences. A second important tool belonging to the PERT is the knowledge base. It's wiki-based, again, due to the collaboration facilitating aspects of that. Indeed, it's updatable by any PERT member, and indeed, if anybody here in this room is interested in being involved and contributing to the PERT knowledge base, if you drop either myself or Toby an email after this, we can put you in contact with the right people. What the knowledge base is aiming to do is to organise and categorise performance-related knowledge. So as well as having subject matter experts, if the information is on hand, the case manager may not need to bother the subject matter experts who are voluntary. And then finally, there's the public forum. That's just a quick example of some of the tools. I don't know if you can see it there too well, but it isn't a straightforward ticketing system. It's not a perfectly plain one. There's all the things you'd expect from a ticketing system, like being able to see your own ticket list and everything like that. But there's some more details. For example, to investigate performance problems, you need to know more than your average operational problem. You need to know details about what is the end system, what's its operating system, do you know what the network card in it is, and things like that. And so the ticketing system is designed to make it easy to categorize and find that kind of knowledge again when you're looking at a case. Well, finally, I'm just going to go through a particular PERT case, and I think this is a very good one because it illustrates a lot of the components that the PERT has to work on, a lot of the problems faced, and a lot of the reasons why the PERT can be useful. The initial problem statement was that there was some difficulty in transferring files from Fermilab to a machine in Strasbourg. The data itself was a number of 15 megabyte files, and it totaled a few hundred gigabytes. Using ORSync to transfer it. Now from that you'd expect, as far as the bottleneck goes, there's about 100 megs, obviously a fast Ethernet somewhere. You would expect the application to be able to use up that 100 meg because you're going onto a research network backbone, typically gigabit or higher. You're going across a Géance backbone, which was 10 gig or at least 2.5 gig, depending where you are. So at the time, there was no networking reason why the throughput should have been so low. Well, the first thing was test machines were set up in similar locations. The PERT has to be moderately pragmatic. If a particular machine is not available, because these are important research tools, they can't just be made available necessarily in order to facilitate problem solving when they're needed for something else. So there was test machines set up in similar locations in Fermilab and in Europe. The Web 100 suite of tools was used and a few tests were carried out. First thing that was noted was if you transferred directly memory to memory, as in you're not writing to disk or anything like that, you could routinely get 90 meg plus. The tool used to do that was NT-TCP. In fact, it was discovered the only reason it was as low as 90 megabits per second was that the receiving machine itself had limited disk and system I/O, so that was slowing things down. That was being a bit of a bottleneck. Once you do memory to memory only, it's a little more clear. So you've got as far as noticing that you can do 90 megabits a second memory to memory. That's a big improvement on 5. What's accounting for the difference? So an alternative receiving test machine was set up. So you've got a long path, the same long path as the original statement. So still Fermilab, still to a location in Europe. In this case, it's Switch. You've got fast machines on both ends. But both machines were also connected via gigabit at this stage on both ends. So what's happening? And what was observed was that the data transfer going via SSH over the ORSync application, it was slower than could be accounted for by the cryptographic overhead. It was slower than you would have expected, even allowing for it to be encrypted. And what this highlighted was there were some SSH or SSL buffer limitations. and they were impeding the traffic going through. Well, closer investigation again. The Fermilab sender side, the ORSync server there, had small TCP buffers. And not only that, in Renet here, the receive side TCP buffers were too small. Well, it could be that you might have had to have left it there, but fortunately the subject matter experts involved noted that on Linux you can use auto buffer tuning on send and receive. So that was done, and you could just leave it there, but again, if you do some calculations, it was discovered you needed about 8 megabytes of buffer space if you wanted to fill gigabit Ethernet across an ocean. So you've got the capacity, the latency, the buffer size all coming together. And finally, the throughput was memory to memory, 429 megabits a second. And the important one for the case of the application, disk to disk, around about 20 megabytes a second or 160 megabits a second. A big improvement on the original 5. Now, why I think this case is particularly good is, again, it shows a lot of things that were important to the PERT to be involved in this. It was 2 different sites. Different sites can coordinate with each other, but it's hard to contact everybody along the path. There are also lots of different components as well. The networking components needed to be checked. The OS components need to be checked. The application itself, anything that the application was using. So it was a very large problem domain. Well, what have we learned so far from 2002, from the original Task Force NGN pilot PERT? First thing is, in a wide problem domain, the existence of subject matter experts, people who are willing to work with the performance team to try and pinpoint, identify and remedy faults, they're absolutely crucial to the success of the PERT. So if you or anybody in your organization thinks you might be able to volunteer time towards this, please again contact Toby or myself. Particular areas we're looking at is networking, applications, protocols, systems, so it's quite wide-ranging. And the second thing is, this is the only service of its kind in the world that we know of. So each new case is new information. It helps to build the service, it helps to enhance what we know, it helps to improve our experience. So with enough cases, the more cases the better, because the more cases then the greater the experience, the better the knowledge we have to solve your problems. And the second thing is, we are here to help. We're open for cases. So again, if you are a research network and you haven't heard how to contact the PERT, again, drop Toby or myself a mail. And if you're not a research network, get in contact, and you're having performance problems across end-to-end applications or anything like that, contact your research network, have them contact us, we'll investigate it for you. Okay, thank you very much. Has anybody got any questions? This is an important bit, by the way.
Hello, I'm Andreas Polirakis from GRNet. So the question is, based on your experience already, can you give us some statistics about the problems? I mean, do you usually, for example, do you find that the problem is on the user side or on the core of the network? Are they related to applications or to probably to router bugs or misconfiguration? Or how long do you take to solve a problem?
This is quite a difficult question for me to answer, because as you notice, I keep saying give more cases. We haven't got a statistically significant large enough case body to really judge that, but some of them, they do take longer to solve than operational problems, because, well, operational problems tend to be either yes or no. Something works or it doesn't work. It doesn't sit in between and then not behave exactly as you'd expect. Some of the other things have been improving throughput for the EVBLI project. Was involved there. There was another case which turned out to, I think this was the case that revealed packet reordering in Juniper M160. So that's an actual fundamental built-in problem to a piece of hardware. So that's what I mean. There is a range of problems. Everything is new so far. We need some more cases to find patterns.
Sorry. The ones I've seen.
Can you hang on for the microphone?
So just a comment that most of the ones that I've seen have to do with operating systems and hosts out of the box that are not well tuned to get high performance. Right? Even current Linux kernels, they will auto-tune up their send and receive buffers to use very large send and receive buffers, but you still have to go into the /proc / whatever to set those upper bounds appropriately. They come with 200 kilobytes and they need to be 8 megabytes. So not in all cases, but in a lot of the ones that I've seen, it's setting some parameters on the end systems, and it's not broken users or broken applications or broken networks. It just tends to be that these things, when they come out of the box, they're not set to go fast over long distances.
Petr Holub, CESNET, Czech Republic. I was wondering if you are going to provide some more user-empowered tools for detecting problems. Because what I've encountered recently was I was doing some ad hoc demonstration of HD video transmission from Europe to the US, and actually because it was kind of just a ad hoc thing, I didn't have time to plan it well in advance, and I even didn't know the IP address and the network setup that will be on that site. So finally I found that theoretically there was all 1 gig connection to Europe. I had serious problems with dropouts, and it was not related to TCP because it worked on UDP as well. And finally I was saved by guys from Canada, which had some pinpoint finger pointing tool, which showed one CESNET router behaving bad, and we were able to correct it. And if I had a machinery of several people, which the case needs to go through, it's much less flexible for this kind of case. So are you going to provide some more automatic and more user-empowered tools?
The PERT itself doesn't, at the moment, provide direct tools. What we'd hope to do is, via the knowledge base, provide a repository and information about what tools are available. I think the Géant project as a whole, I think it's JRA1 is involved in test and measurement, and some of the tools that they're producing maybe have helped you. If anybody else who's in the audience involved in those areas wants to chip in. The I haven't got a setup prepared, I'm afraid.
Thank you very much.
You're welcome.
It's working.
Okay, so I'll be presenting you the work done by the GN2-GRA1, which is the joint research activity on performance monitoring and management. And you can see there's also a small an Internet 2 logo there. It's because we are currently working in coordination with Internet 2 on this project. Because we think it's much more powerful to be, the more we are to be deploying such a system, the better it is. So that's why we decided to work with Internet 2. So most of the work there, everything related with the framework that I will describe, is a joint work with Internet 2. Which are the motivation for taking over this GN2-GRA1 activity on multi-domain performance monitoring? So the observation is, I mean, it's basically what Anne has been described over the previous slide. So it's end-to-end troubleshooting. It's not straightforward at all. Where is the problem? Is it within the end system? Is it on the network? That's something we need to figure out, and we need, if possible, with our GRA1 app, is to try to show as quickly as possible that a problem is or isn't on the network itself. And then we've got also network operators who don't want to spend too much time on a problem which is not located within their own domain, and be able to give the problem to where the problem is as quickly as possible. We've got also we make also over the last year the constatation that the researchers want to have access to more and more data for their own research. So for traffic engineering purpose, for anomaly detection, they wish to have access to real network information in such a way that they can enhance their research or the algorithms on which they are working, and test them against a real case and real utilization. And we've got also the end user, which don't have much view about the network. In the best case, they can have a view about what's happening within their local network, or maybe within the NRENT, but once they have to go one network further, it's kind of the unknown country, and it's a kind of completely black for them. And the current monitoring tools and visualization are kind of dictated by the tools itself or by the provider. When it's dictated by the network, the tools itself, you've got the component to capture the information, the one to store, the one to analyze the data, and the one to visualize everything in a single package. You want to do something slightly different, you need to restart the whole stack all over again. So what we would like to do is to try to kind of decompose those different elements in such a way that if you've got one day a bright idea for a visualization or for a tool, you don't have to think about rebuilding the whole stack, and you could just concentrate either on the tool or on the visualization without having to care about the rest, the other pieces. And finally, we also want to provide some facility to retrieve monitoring information from different networks. So currently, let's say you want to have access to some data from, let's say, GEANT and Internet 2, assuming that you could access them. You would have to face the GEANT proprietary way of storing and providing you those data, and then the Internet 2 one. And once you've got those one, you need to understand how they store, how they provide you those data, and then transform those data to put them in a format that you can make use of. So we would like to provide the data into a single predefined format in such a way that when people need to have access to those data, they know which format the data will be provided, and they can just retrieve it. Okay, so it's just to outline you a bit the current view about the information you can find in the network today. So you've got an end-to-end path here, and basically you don't know what's happening there except if you are one of the local manager of this network, and what's happening there you don't have any idea. So we are as GRA1 and in partnership with Internet 2, we are trying to propose a suggestion to solve a different issue I've been mentioning earlier on. And we intend to design and implement, not intend, but we have already started doing that work. So it's not just a prediction for the future. To provide a framework which would act as an abstraction layer in respect with the measurement tools which are deployed within the different networks. And this framework would also take care of all the difficult bits you could encounter, like the service, the measurement point discovery, which are the measurement capabilities of such and such domains, and which one could I access to, the authentication authorization problem. We would try to provide a solution which could be used easily by a network operator. And the most important point we need to take care is to allow each of the network to still have ownership and be responsible of its own data. So they should have the capability of mentioning this person can access this data, this person cannot access this data, or this group of person can do that kind of test, and that group of person can do that kind of test. It's very important in this kind of distributed environment where each network has its own policy to be able to take that into account. We also intend to integrate a few set of tools within the the general framework to demonstrate how it can be done and to provide data to the user, as well as building visualization tool. So what would it look like? Some of you may already been familiar with this picture. So typically, we would have, I don't see it from here, so, you would have on top of it the visualization client that you could be building or that JRE1 could be building. And the visualization client has the capability of accessing monitoring information from different domains through a predefined interface here. So they don't need to care how the data are represented from one domain to another one. And then you can also see that in different domains, you've got different measurement tools being deployed. And that's also what brings this interface here, the abstraction from the tool which are being deployed without the domain. And for example, here one-way delay could be measured with the Internet to IP OAM box. Here that could be with a RIPE TTM, and there it could be measured with the DFN IPPM one-way delay measurement box. So we are trying to take that into account when we are building our tool, and this layer would be acting as an abstraction layer between the visualization here and the measurement tool being deployed there. And this intermediate layer will have several actions. So they will have we are talking in terms of services we are providing to the user there. The first service will allow a user to start and stop a test in the case of an active type of test. We'll have also an archive service where which would be a kind of wrapper around a measurement archive. It can be a round-robin database, which can be a MySQL homegrown database developed by an NRN. We will also have a discovery service which has the goal of answering, okay, that's very nice, I'm in front of this network, but which information can I retrieve from that network, and where are located the place where I can retrieve those information. So that's what the discovery will do. We'll also have an AA, Authentication Authorization Service, which will be provided by the GN2-JRE5. And finally, a transformation service, which allows to transform the data format of the data you want to retrieve if the format which is currently being stored within the domain doesn't correspond to what you would wish to have. So that's simplistically what we would provide. So you could see, if you've got the proper authorization to do so, you could see information from those different networks. And for the LAN, we possibly need to think about another way of making the bridge between the infrastructure deployed within the NRN and the end user, because we possibly need something much lighter which can be installed on the equipment of the end user to run some tests between the end user and a given point within the backbone. So that's why there's this difference between in color between the network and the LAN there. So we had a requirement phase at the beginning of the project, and based on those requirements, most of the users show they are interested in a very specific set of metrics, which is the one-way delay, the IPDV, the one-way packet loss, the round-trip time, and the trace route for everything regarding the delay. Regarding the bandwidth, they mention available bandwidth. And based on the answer they gave or the problem they were facing, the available bandwidth can be decomposed in two different types of available bandwidth. So you've got the IP link utilization, which is typically the capacity minus, the IP available bandwidth, which is typically the link utilization, the link capacity minus the link utilization. And you've got the TCP achievable bandwidth that you could have between two end hosts, like Anne was describing. That's typically the memory-to-memory type of test, which can be done with those, to which this TCP achievable bandwidth does correspond. And then people show also interest in router information, like are there some drops on the interface? Are there some errors in input of the interface? So that's something they would like to check along a given path. And at a later stage, we can also think about including net flow information and packet capture tools, but that's a bit more long-term for us. So I mentioned the different services there, and I'll possibly go first through a kind of small demonstration on how you could make use of those different services. So let's assume you've got 2 networks, and you've got a path from A to F. Okay, so it wasn't very clever to put those letters in black just in front of a dark blue screen, but I'll try to do better for the next time. So you've got this path going from A, B, C, D, E, F across 2 networks. And let's say you've got a problem between those two points and you don't know what it could be. And the first thing you would want to check is what's happening over the network. Are there some packet loss? What's the link utilization or the available bandwidth? Is it something going wrong along that path? And typically, you would like to buy a client for that. But currently, you can buy a client, but you don't have access to those data, and you don't know how to retrieve the data. So that's where GRA1 brings this framework. And the first thing you would be confronted to the framework is a lookup service. Because let's say you've got a question, give me the link, the available, IP available bandwidth along the path A, B, C, D, E, F. You know there is the lookup service. You are aware that within your own network, within the network to which you are connected, there is this lookup service. And you will ask the lookup service, where can I find information about the link utilization along the path A, B, C, D, E, F? And the lookup service will answer you, okay, for ABC, it's not within my domain. Please refer to the it's within the network A. Please refer to the lookup service A. And for C, D, E, and F, that's within my domain. I know about them, and you can find them within the lookup service A. Yeah, I think I was pointing on the wrong line. Sorry about that. So let's resume it. ABC is not within my domain. Please refer to, it's within the network A. Please refer to the lookup service A. C, D, E, F, I'm aware of those data. It's stored somewhere locally. It's, for me, the network B. I think I mixed the letter A and B, by the way. So if it's network A and network B, yeah, I mix them. And I mix the letters there too. Oh my gosh, very bad point for me. Yeah. So for this information, this is the place where the data, the round robin archive for the network B, and this is. And the lookup service, by providing this information, tells you where you can find those services. So for the network A, the lookup service tells you this is the lookup service where you need to ask the data. For the network B, this is the place where you can find the data. But before going there, you need to have the proper token to be authenticated and to have access to those data. So you need to go to the authentication service of the network B to have access to it. And then you can repeat the same step for the network A. Where can I find link utilization along the path ABC? And then for the path ABC, the data are stored into the measurement archive A here. But if you need to access this measurement archive, you need first to authenticate and being authorized by the service which is here. And then that's what I do. I go and authenticate myself against the B authentication server, who give me, okay, this is the token to access the measurement archive. And then can I get link utilization for C, D, E, F? And here you go. Here is the data in a predefined format as you are expecting. And then you can do the same for A. As for ask for the token, which allow you to retrieve the data from the measurement archive here. Now you've got the data, you can process them as you wish, and then you've got a very nice and useful graph that you were expecting to have at the beginning. So this is roughly how the framework would be working. Now, it doesn't mean that you have to deploy within your domain all those services. If all the data can be accessed by everybody, you can only have a measurement archive, and anybody can access it. So you don't need to have this authentication service. And if you also don't want to have the lookup service within your network, you could ask to the next network or Giant, could you please host for me this lookup service, because I really don't have anything as information to put there. So could you host it for us? And then the Giant lookup service, for example, could provide information for your own network. So it's fairly flexible to go in one or the other direction. So we have defined several services which can be needed within this infrastructure. And among the services, there are 4 that we consider as being the basic services, and 3 other ones which can be addition and nice to have. So the first service is the measurement point service. It's a kind of wrapper around a measurement tool or several measurement tools providing the same type of characteristics. It will publish data captured by the measurement tool to data archive or to data subscriber or to clients. And it will also allow a user to start and stop a test when they need to do so. So it will mostly be wrappers over tools, and potentially in a longer term, you can think about having this service integrated into the tools itself. Then the second service is the measurement archive service, which is typically a wrapper around a measurement archive. That can be a round-robin database. You've got that can be a dedicated MySQL data archive. It's anything which stores data in any format, but we export it in a predefined format. The third one is a lookup service. The lookup service helps you to find out which are the services within your network, what information do they provide you, and which type of authentication would you need, and where to find and where to authenticate yourself. And it is expected in the long run to have the different services registering automatically to this lookup service in such a way that you know that the information within the lookup service are always up to date, and you don't need to wonder, oh, I don't get any response from this service. Is it the lookup service which is not up to date, or is it because the service is just down right now? This dynamicity would allow to have always information up to date, and if you plug a new tool, it will automatically register and will be included within the lookup information. Then the authentication service would be developed by GRA5, and we would be using their interface. In the first stage, we would develop our own authentication server, and then, but still be using the GRA5 interface there. And then we are arriving to additional services. The first one being the transformation service, which you've got data stored within your domain, but the client or the user who want to have access to those data do want them in a different format, like a different aggregation period, or he wants to concatenate different type of information, or he wants to correlate or transform the format to receive them. That's what typically a transformation service would do. When I'm mentioning user, I'm not mentioning end user or network user in general, but a user of this general infrastructure. It's to make the distinction, because the user definition is a bit different from just a network. The different groups of users we are targeting are the NOC, the different projects which would need to have access to monitoring information like the EGE project or any other research project. We're also targeting the generic end user, but in which case we would provide them a kind of very high level visualization which should be understandable by them, because it's one of the main issues. We cannot kind of throw loads of information to a generic end user and not explain them. It would kind of overload slightly or knocks with lots of requests, potentially. Another service is a topology service, which provides the topology of a network, where are located the measurement point within the network, close to which router are the measurement point, which are the prefixes close to that router. And that would allow people who are building visualization clients which are based on map to retrieve the topology of a network and map to it the information they are retrieving from the network. And finally, the last services we would go for is a resource protector. Why would we need this? If we think in terms of TCP throughput type of probes, those are quite intrusive, and they can generate up to 1 gigabit per second with a PC with a single gigabit Ethernet card. Do we really want to kind of overload our network with test probe type of traffic? And that's typically where this resource protector service would come into place, to try to prevent different tests to be run at the same time and overload the network. This is a quite tricky bit, and we're not quite sure to which extent we'll be able to make a full and complete solution. But at least we can have something which limit locally the utilization of those resource-intensive type of probes. So what's the current status? So far we have been designing and defining those different services, and we are in an implementation phase where we are prototyping three of those services, which are a basic lookup service, MP, and a MA service. And the technology used were web service with Axis Tomcat. And for the interface, we are trying to follow the interface from the GGF NMWG network monitoring working group from the Global Grid Forum. And we are putting some, with Internet 2, some quite heavy thoughts and feedback in it in such a way that the interface for requesting and giving back the information can fit our needs and does correspond with the type of reality we've got within our network. So for the end of August, we will be building this prototype, which will provide link utilization from several networks, so from Giant, from Internet 2, and from ESNet at least, and possibly from one or two NRN based on the time available to integrate all those existing round-robin database within the measurement archive service we are currently building. The goal of this prototype is to check that the general framework design we have been working on does make sense and covers the different reality we've got within our network and the different implementations. And we also intend to test the communication, because you have seen you've got lots of communication, and we would like to try it out to see if it's realistic and if it's flying. We want also to test the technology to exchange information, because lots of people have been kind of saying, "Ooh, you go for web services, be careful, it won't fly, this is a very bad choice." And that's something we intend to try out. Is it really a bad choice or not to go for that technology? To demonstrate the overall measurement archive things, we will be using the CNM visualization tool built by DFN, which is a map-based type of visualization tool. And you would be able to visualize the link utilization from ESNet, Abilene, and Giant with this tool, and you would be able to jump from one network to another one with this single tool. The partners for the prototype are currently Abilene, ESNet, Giant, GNet, PSNC, and Unit. Those are and DFN. Those are the main partners involved within the prototype. That doesn't mean that they are the only one partner within GRA1. There are 14 different elements involved within the overall activity. But not all of them are involved within the general framework implementation and design. GRA1 is also working on the enhancement of tools to fit within the framework and to provide them additional capabilities. Like during the requirement, people mentioned that the tools we are working on should be capable to support most of the services within the network, which means IPv4, IPv6, IP quality of service, and multicast. So those are the main services we are targeting. For IPv4, IPv6, and the quality of service, it's fairly straightforward. For multicast, we need to put a bit more thought in that. We're also working on the round-robin database type of tools for their integration, and that's what we are working on for the prototype, as well as on the BWSTL, which is a tool developed by Internet2, and it's a wrapper around iPerf. And it allows you to start and stop tests between other BWSTL instances, which can be deployed in different domains. So as soon as your key is included within another BWSTL tool, you've got the capability to start test with this other BWSTL tool, and the local administrator can set up different level of tests you can run with the BWSTL tool. For our second stage, we would include the NetFlow and the packet capture tool. And for the visualization, right now we're working on the integration of the CNM tool from DFN and the Nemo tool from Uninet, who are two network map-based type of tool. They're already existing, and we are just modifying the way they are extracting data from the network. The next steps for December this year would be the integration of the IPPM tool from the BWSTL within the framework, as well as providing the on-demand test capability for both those tools. So you would be able to start tests between instances of those tools. And we will also be working on a path-based visualization client. So the client, you would input to the client a trace route with the metric you would like to see along this trace route, and the client would provide you back a graph showing you the link utilization, for example, if this is the metric you have chosen along the given path. Currently, ESNet has done it for its own network, and it's quite nice and quite interesting to see this. And they would like to extend it up to CERN, because they've got lots of relationship between ESNet and the CERN. So they're quite interested by that feature. So as I mentioned, this is a joint work between GN2 GRA1 and the Internet2 PAT initiative, as well as an active contribution from ESNet. And what drove us to work on this joint collaboration between GN2 GRA1 and ESNet is a kind of revised version of the McLaugh's law, which is that the more instance of the framework you have deployed, the better it will be, and the more added value you would bring to the overall community. So you can find some information about our activity. First, on the GN2 GRA1 main public page, which doesn't contain much as is, but I promise you that we'll be working over the next few months to provide you more information, because now we start having meat that we can start disseminating. We've got also two archive lists which are open. So one is regarding the prototype work, which is being carried out, and it's pretty heavy and technical for people who are interested to follow this. And the other one is a request for enhancement. So we are setting up request for enhancement form, and people using the architecture and the different tools who are working on would be able to make some enhancement, and we would keep track of those enhancements through that mailing list there. The three tools we are currently working on are the DFN IPPM. You can find the information there. Last year, during the GN1 project, we deployed 5 of those DFN-IP PM box are over different endpoints, and you can have access to the measurement results there. We will also be working on the DFN CNM tool, as well as the Unit Nemo. And if you want to have a bit more information about those two tools, you can refer to the two pointers which are there. And that's it for my presentation.
Thank you very much. Any questions?
Hi. I have a question regarding the use case that you presented before, where you have the two clouds and the path crossing the two clouds. In the use case that you presented, you assume that the user in your scenario already knows what is the path involved in the measurement, right?
Mm-hmm.
Because in your example, you assume that this information is provided by the user. Is that a realistic scenario? In general, is the path known in advance? This is one question. The other question is again about the same use case, and you demonstrated that you have a front end, and then if you don't have information for a given portion of the path, you say your provider is another guy, which I cannot remember the name. You say LA, I think. No.
Lookup service.
Lookup service. So how do these services know each other? Do you have a static approach where you have just a configuration file, or any dynamic solution where each component can know of each other?
So regarding the first question and the path, I would say the answer is multiple. It's really depending on the case. So we are not intending to as I show it there, I'm not intending to use that for prediction of future performances, if it's what you are referring to, by knowing in advance what the path will be. No? But we are assuming that if you have access to an end host, you can run a trace route and then give the path as it is right now. Now, we need to be careful with that, because is there some load balancing between two links, and is it really the path followed by the traffic which is experimenting problem? Is it really following the same path and the trace route?
Yeah, in fact, that was my question, not a prediction, but rather sometimes you don't know the path in advance because the real path that is causing the problem
is changing.
Yeah, so I thought that this assumption may be not true in general.
No, that's again that still need to be the information provided needs to be understood properly. And one of the first thing in networking is you know that basically the path can change at any time. So when you do trace route on your day-to-day life, you always wonder, okay, do I need to run several trace routes to make sure that the path is kind of stable? And if it's stable, you can assume that the path you are inputting within the tools is the one being followed, and the information you would get are the correct one. Now, if the path is changing all the time, possibly you don't need to be using such performance framework, because possibly the main problem you've got is because of the routing which is changing, and it's possibly more of a generic network operation problem rather than a real end-to-end performance problem like Anne has been describing during his previous presentation. So you need to be careful in how you interpret that, I would say. It's on a case-by-case basis, I would say. Regarding the second question, that was about the lookup service. Initially, we intend to have the lookup service statically connected with each other as a first part. And then we are currently following several tracks to have those lookup services talking to each other and updating some part of the information they need to exchange between each other. People have mentioned several techniques for doing this. People have been mentioning peer-to-peer, people have been mentioning multicast. We haven't yet decided a given technology for doing this. It's kind of, we are not yet there. We'll first start with a kind of static lookup service where the information is being exchanged statically. And in kind of 4 to 5 months from now, we'll be able to think more properly on the how do we exactly deal with this dynamicity between the lookup service. So we know we have to face it. It's in our roadmap, but we haven't yet spent too much time on it.
Then maybe I have another question, but if there are others who want it. Okay. The other question is about the aggregation, correlation work and other techniques.
Sorry? How?
Yeah, there was a list of different approaches to analysis of the data and how you can aggregate the information.
Yeah.
I was wondering, how do you deal with the problem when you have different performance monitoring frameworks in different network domains, and for a given path you have a value, but that value is associated to a given timestamp, which may be 1 hour ago, and the information you have from the other complementary part of the path is dated 2 hours later. So when you have this kind of a time mismatch, and that's typically the case because you cannot synchronize measures for a number of reasons, and anyway you don't have a universal clock that you can use, how do you deal with that problem?
So there we've got several, there are two approaches. We're in a phase where we're kind of studying the problem. And there's the theoretical approach where you want to have everything perfect, where you will use mathematics to provide you a data for concatenation or for aggregation. That's one part. And then there's the pragmatical part, where currently you don't have any information. So the pragmatical part would be, let's try to provide some information. It's better than not having anything. Now, it depends what you want to do with this data. If it's to verify a SLA, where you will be fined by, if you don't respect it and you will have to pay lots of money for your customer, then the problem is getting very, very serious, and you need to go into the mathematical level very carefully and have a good time synchronization between all the measurement, ensure that the different domain does the measurement in a kind of same way. Now, if you go for the pragmatical approach, for helping the NOC members to understand what's happening, you possibly don't need to be as thorough, because just by providing them the information, maybe first a concatenated information with the list of all the information below, that's possibly good enough for NOC to start with. So it's very dependent of which application you want to do. And the measurement done 1 hour and in 2 hours time are not very frequent in the environment we have. Most of the measurement are being run every 5 minutes. So the kind of difference between them wouldn't be that big. Okay, you will say a packet lifetime is 60 milliseconds, so okay. Now the question is getting more interesting if you say, I want the last value and the one right now, because the problem is happening right now. Then we intend to add the capability of starting a test on demand. And it's feasible for some of the measurement, possibly not all of them. But there are ways of going around the problem based on what you want to do. And I don't think we want to be theoretical at 100% in this activity. We need to be pragmatic to provide an added value based on for the NOC and in comparison with what is already available there.
Any more questions?
Mike.
Apologies for taking up coffee time. I won't be long. You mentioned available resources. Would this include any reference to things like the RIPE test traffic service, which are used already as multi-domain measurements, albeit between fixed points and not case-oriented points, which might come to you?
Sorry, I didn't hear because the
question is about use of available resources, and such a resource used already would be the RIPE test traffic service, test traffic measurement. which doesn't map exactly to your points, but nonetheless is multi-domain and is used for monitoring performance between domains.
I've got some problem understanding the question because there's the right TTM which provide data, and then there's the resource allocation things I don't know.
No, just the right database,
Yeah.
which is already a resource, which is already available.
Yeah. So currently what we have been doing last year on Giant, we have been using data from RIPE TTM boxes, and we have built a kind of wrapper above that one. So we are retrieving one-way delay information from the RIPE TTM boxes from 5 different locations. We've got the Giant TTM, we've got 2 switch TTMs, possibly the IHENet one. I'm not sure about that. Yeah. And there is another one in Nordnet, I think. So we're already capable of retrieving measurement data from those different RIPE TTM and to provide them through this predefined interface. And that's being used currently by the EGE project to showcase the exchange of monitoring information through a predefined interface between the networks and the EGE who needs to access those data. The current problem with that is that on the RIPE TTM you keep the data for a short period of time, and if you need, for example, to the problem is that all the TTM data are stored in a single file for a given day. So if you want to have access to the data from 5 minutes or 10 minutes ago, you need to download a whole file which is around 40 to 60 megabytes, and this is quite painful to extract. So in the longer term, to have the TTM very active, we can make use of the data right now with them. That's not a problem. But for the longer term, the way they store the data within the TTM should be a bit more flexible to allow more easily retrieval of those data without having to download those 80 megabyte file. But we have been asked a lot by the people, can you integrate the TTM within the framework? And our answer is definitely yes, because there are 50 of them within the research and educational environment in Europe, and that would be a pity to forget them. That's important, and they are there. So yes, definitely.
Okay, thank you for these questions. I would like to tell you that the next session is a performance tool. I would like to invite for this next session too. And now I close the session. Thank you.